Wireless. Wireless is next. We've talked about our two kinds of copper, our fiber optic, and now we're on wireless. There are lots and lots of wireless technologies. That's why we have an entire class on wireless. There's broadcast, radio and TV, Wi-Fi, cell phone, satellite, infrared, Bluetooth, RFID, NFC, and there are others. So lots of types of wireless. Wireless tends to work in 3 different bands of the electromagnetic spectrum. Down here in the radio wave area, in the microwave area, and then in the infrared light area. So all of these have their own characteristics and uses. In general, by the way, the higher you go on here, the more data you can carry, but the shorter the distance. Down here you can carry less data, but very great distances. The radio band goes from around 550 kilohertz to 1640 kilohertz. Kilohertz is 1,000 cycles per second. Not used too much for digital communication. We did use it a lot for radio and TV, of course. Microwave is 300. This is a huge area, by the way, 300 megahertz to 1 terahertz. We use this for a lot of our communication. Wi-Fi, Bluetooth, satellite, all of that is microwave range. The infrared range is 330 gigahertz to 430 terahertz. So these are way up there. We're starting to get into the light spectrum almost. And these are only used typically for very, very short distances and within a single room. There are some characteristics of these. Radio waves tend to bounce off the ionosphere. These are very low frequency waves, so they tend to stay bound to the Earth. Microwaves can travel out into space and go on virtually forever, theoretically forever, although there's some point at which you wouldn't be able to tease them out any longer. Infrared is blocked by walls, so it tends to be usable only in a room, only line of sight, like for a TV remote or to move data from, say, 2 phones. Safety concerns. So Wi-Fi, satellite, and others are microwaves. They are the same as the microwaves in your microwave oven. Well, that sounds scary, doesn't it? Now, they are much lower, weaker signals, but this has caused some concern from some groups who are worried about the possible long-term effects of all these microwaves. No research has shown whether there's long-term effects or not. We really don't know what to look for, so how would we know? So it's very difficult for us to discover that. Distance. Because of the highly directional antennas, we can get these microwave signals very, very long distances. So these satellites, in order to be in geosynchronous orbit, have to be around 23,000 miles high. So we can easily move that signal that distance.